Hello everyone. Welcome to Grade 10 Math. This is Unit 1.2, Measuring. I'm going to give you a little summary of what we've done this week. Some of you have been out sick. Good chance for you to catch up. We talked about accuracy and precision as far as measuring and numbers and significant figures. And I'm going to go through a little brief recount of what we did. First of all, I'll give you a definition for accuracy and precision. Accuracy indicates how close the recorded measure is to the true value. It's dependent upon the user's skill in using the measuring tool. So with accuracy, if you know how to use the tool, you'll probably have a pretty accurate result. If we talked about a ruler, if you use the ruler properly, a measuring tape, a thermometer, and we're going to see in a minute about lots of the guys were interested in guns and shooting accurately. So here we'll put a couple examples in regarding that. Precision, on the other hand, is the smallest unit that can be measured with confidence using the measuring tool, and it's determined by the fineness of the scale on the tool. So I have some tools, or some rulers that I handed in my classroom. They have centimeter rulers measurements on them, as well as millimeter. And the centimeter ones, the only thing that's marked is the 0, the 1, the 2, the 3. So it's very difficult to tell what you're measuring and how it's measured properly with that sort of a scale. The millimeter ones are very, very accurate. So in each case, when we choose a tool, we're always going to go to the next level. So if it's measured in centimeters, we'll go out to decimal place. So we'll look at it and say, gee, it looks to be about 1.7, even though the scale is 1, 2, 3, and so on. So we'll always take it to one decimal place. If you're measuring with a millimeter ruler, you would say, oh, that's 17 millimeters, and then we take it to one more place after that. And millimeter, there's not much space, but you can get an idea. Does it look like 17.5 millimeters? So that would be the idea of precision. And as long as you were using that ruler well and you knew how to use it, you'd be very accurate as well. So let's move ahead and take a look. There's different types of scales. Here's some scales for digital scales and some old traditional scales. What the guys were most interested in was this. The couple types of handguns. These are 22s, and they use them for target shooting. And the one on top is a very precise weapon. It has really good sights on it. It has a bull barrel, which means that it's a barrel that is quite thick and absorbs the heat and very well, and it just makes it so that you can hit your target well. It's a target pistol. So it's very accurate because I know how to use it well, and it's very precise because it's an excellent weapon and it's designed to be precise. The one on the bottom is one of my favorite. It's a little Lama 22, and it has quite a short barrel. It makes it quite hard to do well. This barrel starts here and ends here, whereas this one starts here and is almost twice, probably is twice as long. So the little gun on the bottom, the little Lama, doesn't have very good sights. It's got a very short barrel. And even though I know how to use it well, which should make it accurate, it's not very precise. So there's your difference between accuracy and precision. And when we go ahead and we take a look at the results, and this is just a couple examples I grabbed off the internet, but the one on the left, the target is hit, but the bullets are sort of everywhere. And so you could say that it's fairly accurate, but not very precise. On the other hand, the center is tore right apart in the second illustration, and so this obviously was not. It was a good shooter that was using it, but it was also an excellent weapon because everything was grouped together very, very close, and so it was both highly accurate and highly precise. Whereas the first one was somewhat accurate, fairly accurate, but not very precise, bullets scattered everywhere. Here's an example of the ruler that I was telling you about. 1 centimeter ruler, starts at 0, goes to 1. The only increment is in the middle, the half mark. So if we were going to measure something that came out to here, for example, We could say it's certainly more than 6, and it's certainly less than 6.5, but where exactly is it? But when we write a measurement down, we're going to go to 1 decimal place beyond what we're sure of. So we know it's 6, 6 decimal, possibly 3 centimeters. The bottom one's much easier. If I was to put the same mark down here, I could say, okay, that is 60 millimeters, 61, 62, and I would say probably it's about 62.5 or 62.7. So let's put that down as the answer, 62.7 millimeters. Even though these we're measuring the same distance, using a different tool makes us more precise. So I know how to use the ruler, so I'm being accurate, and the bottom ruler has millimeters increments, so I can be very precise. So hopefully you understand those differences between accuracy and precision. We can show you one more example. If it was a bow and arrow, and you got everything right in the target area, they were all grouped well, you'd say there's good accuracy, good precision. If, for example, that the target it was quite a ways away from the center of the target, and the bullets or the arrows were sort of stuck in just about everywhere, as they are here, we would say it is neither precise nor accurate. And the last one, it's grouped very well, so we know that the weapon is working well, but it's not close to the target. So we would say that we didn't really know how to use that weapon well. So I've never fired a bow before, but if I did, and the bow was very, very precise, it had great sights on it, and it was very steady, then probably I would take some time to know how to use those sights, and I would eventually become more accurate, even though it is a precise weapon. Okay, let's fire ahead just a little bit here and get a little summary of some of the things that we were doing during the week. We looked at rules for significant figures. Now, the first rule for significant figures is very, very easy. All non-zero numbers are significant. So, for example, if I had a number like 354, there are 3 significant figures. 1,234, there are 4. All you have to do is count them. 1, 2, 3, 4. It's that simple. It's the zeros that are a little more complicated if we have a 0 in a number. And there's about 5 different rules for you to look at. The only way to learn these is to memorize them. And so you might as well just do that right from the start. All zeros between non-zeros are significant. So, for example, right here, we have a 0 that is surrounded by a 3 and a 5. So it is significant. Therefore, in this example, there are 4 significant digits. 10,003, there are 3 zeros, but they are surrounded by non-zero numbers. So all of those are significant. So it's 5 significant figures there. Next rule, zeros next to the decimal are significant unless there's no decimal point. So here are 2 examples. The first one, 3,000, and the decimal point is at the end. So according to this rule, everything in there is going to be significant. So you have 4 significant figures. So zeros next to the decimal are always significant unless there's no decimal point. And the next one, we just don't know. They actually could be significant, but the fact that there's no decimal place there, we just don't know. So we do know for sure that the 3, which is a non-zero number, is significant. So we know there's at least 1, but according to the rules in math, we're a little bit confused and baffled by this. So all we can say is that there's 1, and possibly the other zeros are, but we don't know. Next rule, zeros before a number in a decimal are significant unless there isn't a whole number to the left of that decimal. So for example, in the first one, we do have zeros next to the decimal. They are surrounded by whole numbers, non-zero numbers, so we can say everything in that is significant. 6 significant figures there. Whereas the next one looks almost the same, but there is no non-zero number to the left of the decimal. So the only one that is significant is the non-zero number, okay, which is 5. Next rule, zeros after a whole number and a decimal are significant Okay, so this means that we're sort of bringing the answer out to more decimal places, which is always a good thing, and it proves, if we're being scientific about it and mathematical, that it is more precise. The more numbers after the decimal, the more precise. So in this case, the first two zeros after the decimal are not significant because of our previous rule that says they have to be surrounded by non-zero numbers. 5, of course, is always significant because it's a non-zero number. And the last one also is, according to this rule, it is after a decimal and after a whole number, a non-zero number. So in this one we have 2 significant figures and 2.30. These zeros are all after the decimal and they're after a non-zero number, so we have 5. So there's quite a few different rules that you kind of have to learn how to apply. And we did that over the course of our week, and we tried a number of those, and we had some warm-ups. And that brings us to our next topic, how to apply those non-zero or those significant figures when we add and subtract. And of course, there's a rule for that. When you add or subtract, find the least number of significant figures after the decimal place and use that amount to round your answer. What's important here is the part that says after the decimal place. And you'll see why in a minute when we do multiplying and dividing. So this question we're going to add. If you did this on your calculator, it would come out to an answer of 30.239 meters. And that looks great, except it's not as precise as we need to be in this unit. So we have to look at this and say, okay, how many significant figures are there in the first part of this question? This part right here. And if we look at this, and when we add and subtract, we're only looking at the ones after the decimal. So 1, 2, 3, non-zero numbers. So this has 3 significant digits after the decimal. This next one has same thing. If we're just looking after the decimal, 3 significant digits. And the last one, there's only going to be 2 significant digits. So there's no zeros here. We don't have to apply any special rules. So the rule here is we're going to choose the least. So 2 would be the least. We had 3 and 3 and 2. So 2 is the least number of significant digits in the numbers making up that question. So our answer needs to be down to 2 significant digits after. So I'm going to draw my line right here. It says after the decimal. And I'm going to say there's 1 significant digit. There's 2 significant digits. And according to our rounding rules, we're going to look to the following number, and it's a 9. So anything that's 5 or above, we're going to round the previous number. So this would be 30.24. Now, how many significant figures are there after the decimal in that answer? 1, 2. That's how many we had to have because we chose the least. So that would be our final answer, being as precise as possible and using our rules. Now, that's adding and subtracting. This time when we're multiplying and dividing, we're going to find the least number of significant digits in the entire question, not just after the decimal, but the ones in the entire question, and round your answer to that number of significant figures. So in this first part, there is 1, 2, 3 significant figures. Next one, there is 1, 2 significant figures. We choose the least amount, so 2, of course, is the least. Now, we use our calculator. There's the answer is going to be 6.762. But we have to be precise about this because that's what this unit's about. And we're going to look at 2. So there's 1 significant digit. Oh, I didn't start the right place. I must have thought I was still adding and subtracting. Here's the first significant digit. Here's the second significant digit. So we're going to round. We're going to look ahead and decide if we need to round. Yes, 6 is larger than 5. So we're going to round that 7 up to an 8. So the answer is 6.8. Does that have 2 significant figures like we had chosen here? Yes, it does. And so that would be our answer. So that's what we did this week. And talked about accuracy and precision and significant digits. And we did lots of practice questions, and we had some quizzes. So I hope you did okay, and if you're out sick, hope you're feeling better soon. See you later.